So today's session is on debugging tools. So you remember yesterday you spent some time preparing a computer environment, finding ways of where you can install softwares, how to use a scheduler. And today's session is going to be about how to look into your codes and understand what's going on into your code. So when you start programming, I think the later sessions will be talking about some parallel programming. And so I just want to show you how you can efficiently record your algorithms and try to understand what's going on in your codes. So the objective is to monitor and to learn how to monitor and study the state of your program in a step-by-step basis using open source debugging and profiling tools and the tools of interest. The first one is GDB. This is a new source level debugger, which you can use. You can also use it to look at your instructions one by one if you go to lower level. So this is a simple tool, and I just want to show you some simple commands you can exploit when using GDB. So of course you launch GDB by typing GDB in your command line. And once it comes, once you do that, it comes with an interactive shell session, and there you can load you can load your executable using the command file. But most importantly, you can also use help function. Help commands to check to see how you can use various commands as well. You can run your code within the session. You can create some breakpoints. You can also create breakpoints at specific addresses. You can step into functions, or by going step by step from instruction to instruction. You can also use a text user interface. We're going to see how that works. And once you're done, you can also quit using quit command. So I'm going to turn into my shell command line, and then I show you how to do this interactively. Give me a moment. So I'll just log into the system, GSCC. And here I have some prepared codes. I'll just remove.
Check, can you increase the font size of the terminal slightly?
Yeah, let me do that. Is that better?
It's great, thanks.
Okay. Okay, let me just, I want to show you how to compile this as well. I'll remove the executables. So here I have two simple codes. So this one is just trying to use an initialized variable to try to write some memory location into the standard output, but there's an initialized variable in there. So I'll just simply compile this GCC. That's simple. And once that is done, then you simply just get to the GDB command line. And here, so the most important thing you can do here is to just get some help in a command. For example, let's say help. Okay, so there you can see different things you can do with GDB. So the one that similar to some useful commands I've talked about. And let's try to load the executable we just compiled. So you can see that it's telling you that it's trying to read some symbols, but there are no debugging symbols found. So it means that there's something else we need to do. So let's quit and see what we can do about that. So I will recompile this again. So the most important thing to remember here is that you need to tell, when you're compiling, you need to tell the compiler to add in some you need to add some debug options for your while compiling. So this you can do by the option G. So I'll just do that again. I'll try to remove this executable and recompile it to the option G. So this should give us the symbols we need, and then we go back to GDB and try to load the file again. Okay, now it's not complaining. And so you can also use how to find out what you can do again. And if you simply just run Python, then you can see that you're executing your program in the GDB shell, and you can you can also create breakpoints here by simply just saying B and picking a code line, a code line. So if you know your code, if you know right now you can see it, but if you know how, you can actually have you can open it elsewhere in another window and just look at it. But we am going to do another thing here which can help us see where we can create breakpoints. So you can have different layouts. So if you type help layout, you'll see that there are many ways you can create layouts for in GDB. And this might not work here because I forgot something. So if I quit again, if you want the text user interface, you need to start GDB with an option TUI interface. And now it gives you some visualization. And if you Now try to, help layout. You can check the available options for your layout. Yeah, so I mean, we have different options here. SRC will display the source and command windows. ASM will display assembly, the assembly and command windows split. We have split and regs as well, which display register window. So I'll take the option split, and if you say layout split, now you can see that you have the assembly and the source windows available for you. And if we load our executive again, you can see that the source code is shown up there, and you also have the assembly window shown below it. And if you, for example, want to create a breakpoint, so we can see our source code up there. So let's say we create a breakpoint at line number 8. So it tells you there that the breakpoint has been created at line number 8, and you can see B plus symbol somewhere, which shows you where the breakpoint is created, and you can also see it in the assembly window down there. And when you run your code, you can see that it stops at that breakpoint. And at that point, you can do many things. You can, for example, print. You can print, for example, the value of a register. Let's say PRX. Don't worry about that. I mean, you can check it later what that means. But usually that shows you where is a system call. So in this case, because at this breakpoint, you see that we are making a system call, a write system call, and usually this is integer number 1, and here we see that it's something else. So it means that something is going wrong somewhere. So this, I'm just showing you different ways of how you can debug your code, and you can go as low as just looking at the assembly code and finding out what's going on there. And at the same time, you can also, you can see where in the high level language at which line there's a problem. So that's a simple introduction to GDB. And I'll quickly go back to the presentation. Yeah, so this is just some of the commands available, and you can look at the GDB user documentation to check on more options. And you can also just issue the help command within the GDB shell, and you'll see the options you have. Yeah, so this is just what I've shown. Remember, you have to compile your code. You need the -G option to, for you to get the debug symbols. And you've seen that if I didn't do that, when I did not do that, when that was not given, the GDB then later complained that the symbols are missing. What about Valgrind? Valgrind is also another powerful tool. So actually, Valgrind is a collection of tools. It's also open source. You can use this for instrumentation and profiling. So it gives you some dynamic analysis of your code as well. And the default tool there is called memcheck, which is gives you an option to detect memory management problems which you could have in your code. Usually such kind of problems are very, very difficult to detect, especially if you have a bigger code. You might fail to understand why your code is failing, or where the which part of the code is throwing an error. And some of the things which memcheck can help us do is, for example, to detect leaks in the memory, or misses of uninitialized values, access, incorrect access of the memory, or illegal freeze on heap blocks, or illegal reads and writes. Yeah, so I'll quickly show you how this can be done as well. So this is an example code which is available in Valgrind's documentation, and it's trying to it's the same code I've shown you before with GDB. And if you use Valgrind, you do the same thing. You have to compile it with -G option. In our system, we have Valgrind as a module, and you can install. I mean, you can just load the module and run Valgrind. I mean, debug your code using Valgrind as shown here. So you just issue the command Valgrind and then run the execution line for your executable. So this is a default run, which means that Valgrind will always be using memcheck tool if you run it this way. But you can, I mean, there are also other tools which you can select. So I'll quickly show you how to do this as well. So I'll go back to the shell. Okay, so I'll quit that. So we are in, it's sometimes, I mean, you can as well do this in a compute node, but I think I'll just do it here. So let's see if we have Valgrind. So Valgrind it's installed version 3.17, and then you can just load it, and you can check whether it's loaded. So it's loaded there. Yeah. So let me try to install. Sorry, to compile another code which has a buffer overrun. So we see how Valgrind can help us that. Okay, so I'll start Valgrind with default option. Let me see if I can get some help option first. Okay, so if you type Valgrind help minus -- help, then you can see the options you have. So you can, for example, if you want to select a different tool, you can just come here, -- tool, the name of the tool, and how many tools do we have, for example. Yeah, I don't know how you can get the tools we have here, but of course you can always look at the user documentation. So I know, for example, that we have memcheck and another one called cache grind, which is also good for detecting memory access patterns. So I'll use the default tool. So if you don't want to use the default tool memcheck, you can just add the option tool there and then select what you want to use. So in this case, I just have some redundancy and try to code. So you can see here, it gives you summary of what's going on with your code. So usually you should just come to the end, like the last line here, where it shows you the number of errors which have occurred in your code. So here it's showing that it's one error from one context. And the error is so yeah, I mean, you have to look at the the traces shown, and then you have to go line by line in your code to see where where Valgrind is showing an error. For example, here it's saying that there's an invalid write of size 1, and you see where it's occurring in line 5. And I think this is yeah, in line 5 and 4. So if you look at our code again, let me see if I can set line numbers. I don't know whether that was okay. I can't remember the option for setting the line numbers in Vim, but here you can just count. So that is 1, 2, 3, 4, and 5. So this is where there's a buffer overrun. Yeah, so these are just simple examples of how you can use Valgrind as well. However, today we have a tutorial which gives which give us more additional ideas on and give us more perspective on how to use Valgrind and GDB. So I'll just go back to the presentation. So the tutorial is in GitLab, should be. So what you have to do, compile the programs. So there are two programs there. I think Jonathan already shared with you the slides and the tutorial file. Is that correct, Jonathan?
I put them on the website, but I think that link you put in there is not public.
Okay. You mean the GitLab page is not public?
Yeah, that's our internal link.
Okay.
If you can zip up the source code, I can just put it on the website as well.
Okay. Yeah. Let me. So I'll take. Let me take about 2 minutes to do that. So they're just simple two source codes, matrix, some matrix manipulation source code. And what you have to do, you have to compile the programs as I've shown you. Make sure you have the MNSG option to get the debug symbols. Then use GDB and Valgrind to study the execution states and memory access patterns. So you can do this in you do this in the compute node. You can just have, like Marcus shown you yesterday, just use LAM and S1 and get an interactive session in one of the compute nodes.
Or you can put it in a Scratch node, make the folder accessible to everyone, and then they can copy it out.
Yeah, I can do that quickly. Yes, let me try and do that. Sorry, I need to switch off that again. You know, I think it's gone. Yeah, so I'll share my my shell again, and here. Okay, let's quickly go through this. So the first tutorial is, of course, it's on GDB, and yeah, the first task is to just play around with the tax user interface, and we've done that already. And I'll show it again quickly. Yeah, so if you remember, you have to use the option for you to see different windows. And remember, when you type help layouts or layout, you see the options. So, and then usually I go for a split option. So layout where we have the source and the assembly, the assembled code. So that was the first step in the tutorial, and then something interesting was to change the syntax, assembly syntax to Intel. So if, for example, let me just look at this, the codes I used before. So if you go to GDB GUI and you try to load files, change layout to split. Then you can see your assembly code here, and usually the default assembly syntax in GDB is what we call AT&T, but you can also change this to Intel assembly syntax. So if I quickly log into the system, I'll just show you how to do this. So in your home directory, you can always create a file. I think I have it already, and I'll just add it like something like that. You just create a dot file for GDB and then add this, set the assembly flavor to Intel. So if I just move that to that, and we see if this can do something different. File, install, and layout split. Now you see it's different. So the assembly syntax is now changed. And I think this is easily readable compared to the AT&T syntax. Okay, so and the following steps were introduced. You were to introduce breakpoints at various positions of your program. You have done that, you've seen it. And you can also print out register contents. In tutorial 2, you have to compile the two source codes. I've shown the matrix initialization source codes. So I use the same method, GCC. Yeah, for example, the column-wise initialization. Sorry, yeah. With your G option. That's okay. Yes. Anyway, so we have the executable there, and if you go to if you want to use Valgrind, we check whether the module is loaded. Yes, it's loaded. And now we want to use a different tool, which is called cache grind. This is the way to select a different tool, not to take the default mem check, and then you execute your code like that. Oh, sorry, yeah, cache grind. And you can do the same with the other codes so that you can compare. Yeah, it might take a while, a few minutes, but then in the end you'll see that the execution is different because the code. Okay, actually, you can see the difference already. So the one which is initialized by the row is executing faster than the one which is initialized by the columns, and the difference is that there's some difference in cache misses here. You can see here the number of cache misses is higher than this one. So this one is not missing a lot of. I mean, it's not having. It's comparably missing less. Missing cache less number of times compared to the other one. So this is just one way you can always debug or profile your code and assess what's going on. So I think we shall end there for the next session.